In the problem 1993, AB23, the question asks how many critical points does the function f of x equals x squared to the fifth times x minus 3 to the fourth have. Alright, so here we have the original function here, and we're asked about critical points. We're definitely going to need to find the first derivative here. So we start with x plus 2 to the fifth times x minus 3 to the fourth. The basic structure of this derivative is going to be a product rule. And so that will be 1 d2. And the derivative of x minus 3 to the fourth is 4 times x minus 3 to the third times the derivative of x minus 3, which is 1. So we have 1 d2. Now we need 2 d1. Sorry about that. And we want 2 d1 now. The derivative of x plus 2 to the fifth is 5 times x plus 2 to the fourth times 1. And obviously you don't have to put those 1's there. Now what we want to do though is each of those terms have a factor of x plus 2 and have a factor of x minus 3. And now I'm going to factor those two out. I want to factor out the greatest common factor. For the x plus 2, it's going to be x plus 2 to the fourth. And for x minus 3, it's going to be x minus 3 to the third. And at that point, we're left with an x plus 2 times 4, then plus x minus 3 times 5. So the first two factors there, x plus 2 to the fourth and x minus 3 to the third, those will have zeros when x is equal to negative 2 and x is equal to 3, respectively. For the third factor, 4 times quantity x plus 2 plus 5 times quantity x minus 3, we have to multiply those two out and simplify. And it doesn't really matter what that comes out simplified to. I think in this case it's 9x minus 7. But it doesn't really matter. We're going to have three critical points here. X equals negative 2, x equals 3, and x equals 7/9. We're not really asked for what they are. We're only asked how many there are, and there will be 3. So this process of finding the derivatives using the product rule and then factoring out those factors is very important. And you can see that we end up with 3 critical points, and we're all done with this one.